Now, today we will be learning about effect of heat on an object. What will happen to an object if it is provided with heat? First, we need to go back to the basic concept of heat. What was heat? Heat energy was the kinetic energy of the molecules. Like every object is made up of molecules. Too many molecules together make up the whole object, and every single molecule is a very small chunk of mass moving with very high speed. So if there is a mass with speed, it possesses a specific kind of energy. That specific kind of energy is kinetic energy. Every single molecule has energy, and when we add energy of all of the molecules in an object, that total sum is called heat. So when we provide heat energy to an object, what happens to the object is the molecules of that object gain heat energy, their kinetic energy increases, and as mass cannot increase, so what increases? Their speed increases. So they vibrate with greater speed, they hit the neighboring molecule more often, they get apart from one another, and this is the basic of thermal expansion. This is why the object becomes bigger. Now, we will not be discussing thermal expansion today. I am making a model of heat. This is an object, and this is a, a syringe that doctors use to inject medicine into human body. Now, this is the plunger, and this is just a model for understanding. This is not the way of injecting heat energy. This is a heat syringe. This is where we have heat. This is heat. If I move plunger this way, heat energy will go into the object. This is object. Now, if I push the plunger in, heat energy will go into the object. If I pull the plunger out, heat energy will come out of the object. I hope you don't take it seriously. I mean, you should know heat is not provided with a syringe. If we want to provide something with heat energy, we put it on a stove. We connect it to a heater. We put it on in a place where there is more temperature. And if we want to cool down something or take heat energy out, what we do is we put something in a region where there is less temperature, like in fridge or freezer or on North Pole, for example. So if we want to take away heat energy, we put something in cold area. If we want to inject something with heat energy, we put it in a hot area. But just to simplify things, I am using this syringe. So if I will push this in, object will gain heat energy. And if I pull it out, object will lose heat energy. Now, object is provided with heat energy first. Object is provided with heat. What will happen if object will be given heat? One of the possibility is temperature might increase, and another possibility is one possibility is temperature increases. Another possibility is temperature stays same. So these are the only two possibilities that can happen. Number one, on providing heat energy, temperature of an object can increase or it can stay the same. Huh? Stay the same? How is that possible? How temperature is staying same if I'm providing it with heat energy? Let me give you an example. Let's say I put a pitcher of water into a kettle and then put it on the stove, and then I put a thermometer into it and let it heat up. So I noticed that the initially temperature is 20, then it becomes 30, and then 50, and then 80, and then 85, and temperature is increasing. That is very normal. That is what should happen because I'm providing it with heat energy. And then temperature becomes 90, good. Temperature still increasing, 95, good. 98, good. 99, and then it becomes 100, and then it becomes 100, then it becomes 100. Is everything all right? I check the thermometer, it is constant at 100. Then I check the stove. Is the stove on or not? Stove is still on. It means I'm still providing heat energy to the system, but why temperature is not changing? Why temperature got constant at one particular value? And when does that happen? What are the conditions for that to happen? We provide heat energy to an object, temperature increases, that makes sense. But if temperature does not increase, how can we explain that? What is happening? What is happening to the heat energy I'm providing to the system? Now, here are the details. If temperature is not changing, then state changes. And if you are a physics student, you should keep in your mind that in one case, only one thing can change. If temperature is changing, it means state is not changing. And if state is changing, it means temperature is not changing. Both of the things cannot happen together. Okay? Even if in a sample, we observe that some region is completely, like, for example, if some ice is melting in a container, in a large container, we will find that some region of melted ice, which is now water, is at a higher temperature than some of the liquid which is close to the ice. And that is very normal because it is a very large body in some areas, because that water is completely changed into another thing, so it can have a change of temperature now. But where this process is happening, the molecules that are getting away from the ice, the temperature will not be changing if it is still melting. So state changes only if temperature is not changing, and temperature changes if state is not changing. Both of them will not be happening together. Is that understandable?
Yes, sir.
Good. Now these two heat energies have their own separate names. This heat energy is called thermal capacity or specific thermal capacity. And this heat energy also has name. It is latent heat or specific latent heat. So let's study them and define them and find their formulas. Okay?
Okay, sir.
Good. Now, what is meant by thermal capacity? Let's define thermal capacity. Thermal capacity. Amount of heat energy required by an object to gain unit rise of temperature. So remember, thermal capacity is amount of energy required by an object to gain unit rise of temperature. And this is when examiner asks you to state what is meant by thermal capacity. Okay? If examiner says what is define thermal capacity, how will you define thermal capacity? Thermal capacity is heat energy divided by change in temperature. Because remember, this is only done when temperature changes. If temperature changes, then thermal capacity comes in. And if thermal capacity is there, we want to know how much energy is given to the object to gain unit rise in temperature. 1 degree Celsius or 1 Kelvin temperature, to increase 1 Kelvin temperature, how much energy you need to supply. And this can be the opposite as well. How much energy we are supposed to take away from an object to decrease the temperature by 1 degree Celsius or 1 Kelvin. Same concept. Okay. If we take the exact same amount of energy out, temperature decreases by 1. And if we provide exact that amount of energy to the object, temperature increases by 1. So there will be the same amount of energy in or out to increase or decrease the temperature. Now, symbolically, it will be capital C equals to heat energy divided by change of temperature. Okay. Now, unit for energy is joule. For temperature, we are allowed to use degree Celsius. So it will become joule per degree Celsius. Now, what is specific heat capacity? Specific heat capacity. We were doing heat capacity first. Now we are doing specific heat capacity. And don't be confused if examiner sometimes use thermal, sometimes use heat. It is the same thing. Okay. Specific heat capacity. Amna, did you say something?
No, sir. My mic accidentally unmuted.
Your mic accidentally unmuted itself.
G, sir. My hand
Okay.
clicked it.
Now, specific capacity is amount of heat required by unit mass of a substance to gain unit rise of temperature. Okay. Now, the formula can be written like this. Specific heat capacity equals to heat energy divided by mass and change in temperature. So it is small c equals to heat energy divided by mass into change in temperature. Now units. This must always be joules. This can be grams or kilograms. This will always be in degrees Celsius. So there are two units for specific capacity. One is joule per gram per degree Celsius or joule per kg per degree Celsius. Okay. So if we take mass in grams or mass is given in grams, we can use this, or otherwise we can use this. And remember, joules per gram per degree Celsius multiplied by 1000 makes them joule per kilogram per degree Celsius. Any confusion? Any problem?
No, sir.
Now, what is latent heat? Latent heat. Heat required to gain or lose to change state at constant temperature. How many states are there uh, that you have discussed till now? Solid, liquids, and gases. Solid to liquid, this process is called melting. Liquid to gas, boiling, condensation, and liquid to solid, so these are changes of state. There is sublimation and solidification. We are not discussing that because they are not part of your syllabus. So solid, liquid, and gas, melting, boiling, condensation, and freezing. All of these processes happen at constant temperature. I'm not saying they are happening at the same temperature, or they happen at different distinct temperature depending on the material. But whenever they happen, temperature does not change. Now, what is specific latent heat? What is this? Specific latent heat. Amount of heat required to change state of unit mass of a substance at constant temperature is called latent, no, specific latent. specific latent heat equals to heat provided divided by mass that has converted from one state to another state. Okay, any confusion?
Wait, sir, why is there a change in mass?
Listen, if we have 1 kg of ice and we provided 1000 joule of energy and remaining ice is 0.998 kg of ice, then our provided heat energy did not melt the whole ice, it only melted the difference of mass.
Okay,
Listen,
sir.
if you have a certain sample of some liquid and you want to vaporize it, you provide it with certain amount of energy and the mass reduces because you have converted that liquid into gas, and the liquid that you converted into gas disappears. It will fly off. It will just poof, go. How will we know that provided energy melted how much of the mass?
Oh, okay, sir. That makes sense.
You will measure the mass before you start boiling. You will measure the mass after you have provided a certain fixed amount of energy, and you find out that this amount of energy has actually evaporated this much of the liquid. So that is how you can find out how much energy you provided to a particular mass or unit mass. Okay.
Gee, sir, it's clear now.
Okay, so tomorrow we'll be starting from the same point and discussing about heating curves. And till then, take care. Allah Hafiz.
That is, sir.